You know, technology is moving so fast, it can feel like you're just swimming in a sea of buzzwords. You've got AI, crypto, neurotech, and it's a lot to keep up with. But what if these aren't just separate random things happening? What if they're all puzzle pieces, all connected, building towards something, well, something huge? Today, we're going to connect those dots. We're drawing on some really sharp analysis from the Atharv Gan blog to piece together the building blocks of what's coming next. So that's the big one, isn't it? Where is this all really going? In this explainer, we're going to break it down. We'll look at the foundational layers, the stuff it's all built on, then we'll look at the new economies popping up on top, and finally, the absolutely incredible new ways we're going to interact with all of it. All right, let's jump in. First things first, none of our digital world, not one bit of it, works with a real physical foundation. We're talking about the massive, powerful, and pretty much invisible infrastructure that runs everything, from your Netflix binge to the most advanced AI on the planet. And it all starts with the heart of the modern cloud, the data center. Now, when I say data center, please don't picture some dusty server closet in an office somewhere. We are talking about hyperscale facilities. These things are the invisible, city-sized engines of the entire internet, run by the big cloud providers to handle the absolutely insane load of our day-to-day digital lives. But see, their power isn't just about being big. It's about being incredibly smart. They use standardized, modular parts, kind of like high-tech Legos. This lets them expand at a crazy speed. Plus, heavy automation means a tiny team can manage millions of servers, which creates this shocking level of efficiency. And that is what gives us the economies of scale that make all the cloud services we rely on even possible, let alone affordable. So, hyperscale is the absolute powerhouse of today, no question. But what about tomorrow? What happens when we start hitting the absolute limits of what our current computers can do? Well, the next giant leap is already on the horizon, and it plays by the totally bizarre but wonderful rules of quantum physics. To really get the massive difference here, just think of a light switch. A classical bit, the foundation of every computer you've ever used, is either on or off, a 1 or a 0. That's it. Simple. A quantum qubit, though, well, it takes advantage of this wild property called superposition. It can be a 1, it can be a 0, or it can be both at the exact same time. And that one little difference, it unlocks a level of parallel processing that is just, it's almost impossible to imagine. It promises to solve problems that are literally impossible for even the biggest supercomputers we have today. Okay, so we've got this incredibly powerful digital foundation. Fantastic. But so what? How does it actually change something as old and fundamental as money? Well, this new infrastructure is letting us completely rethink how we deal with value, how we transact, how we lend, how we borrow, in a way that's born digital from the ground up. One of the first and biggest problems in the crypto world was just how wild the prices were. I mean, you can't build a real financial system on something that can swing 20% in a single day. So what was the solution? Stablecoins. These are cryptocurrencies that are specifically engineered to not be volatile by pegging their value to a real-world asset. This makes them way more practical for things like decentralized finance, or DeFi. But, stablecoin isn't just one thing. The real question is, what actually makes it stable? Some are pretty simple, like USDC. They're backed one-to-one by actual dollars sitting in a bank account. Others are backed by physical things, like gold. And then you get into the more complex stuff, like coins backed by a whole basket of other crypto assets, or the purely algorithmic ones that just use software to hold their value. Each one is a different bet on how to create real stability online. And yeah, each comes with its own set of risks. But here's the thing. The innovation isn't just about creating new kinds of digital cash. It's also about creating totally new ways to interact with it. The next step is to make paying for something as natural and as simple as just having a conversation. And that brings us to this next layer, conversational voice payments. Seriously, just imagine paying your phone bill just by saying it out loud. An AI listens, it understands what you want to do, it confirms it's actually you using your voice as a password, and boom, transaction's done. And this isn't just about being convenient. It's a massive leap forward for accessibility, for visually impaired users, or really for anyone who finds navigating a bunch of confusing apps a real pain. So we've covered the foundation and the new economy. Now for the last piece of the puzzle, and honestly the most futuristic one. How are we going to interact with all this stuff? I mean, the keyboard and mouse have been great, but the next interfaces are going to be way more direct, connecting right to our bodies and, yeah, even our minds. A brain-computer interface, or BCI, does exactly what it sounds like. It creates a direct line of communication between your brain and a device, letting you control things with your thoughts. And look, we're not just talking about sci-fi implants here. This tech is moving forward in non-invasive ways, like with neural earbuds that can literally read your brain signals from outside your body. It might sound like something out of a movie, but the process is actually pretty logical. First, tiny sensors listen to the faint electrical signals from your brain. Then, some really powerful software acts like a translator, filtering out all the noise to figure out what you're actually trying to do. Finally, it turns that intention, like move the cursor up, into a direct command that the device just carries out. BCIs are incredible, for sure, but they need a lot of processing power to work. And usually that means sending a ton of data to the cloud and back, which is slow and, let's be honest, raises some privacy questions. So what if the AI could do all its work right there, on the device itself, with no internet needed? And this is exactly where TinyML comes in. It's a field of machine learning that's all about shrinking these powerful AI models down so they can run on tiny, low-power computer chips, the kinds you find in your smartwatch or smart speaker. This moves the intelligence from the cloud to what we call the edge, and that is a total game changer for privacy, for speed, and for saving energy. Okay, let's take a step back for a second. We've looked at all these individual building blocks: hyperscale computing, quantum physics, programmable money, and interfaces that can read our minds. So how do they all fit together? Let's connect the dots. So here's the big picture. It all starts at the very bottom, at the foundation. We have this invisible global infrastructure that has immense power, and it's evolving from today's hyperscale cloud towards the reality-bending potential of quantum computing. Now, on top of that powerful foundation, we're building a brand new programmable economy. Not with those crazy volatile assets, but with stable digital value that we can use as easily as just having a conversation. And finally, the wall between us and that whole digital world, it just dissolves. With BCIs translating our thoughts directly into actions, and TinyML giving us that instant, on-device intelligence, the line between thinking something and doing something starts to get really, really blurry. The really crucial point here is this. We're not just getting slightly better gadgets. We are fundamentally changing how humans and computers interact. We are moving toward a world of hands-free, intuitive, non-invasive control, which is exactly what this key insight from our source material points out. So when our computers, our economy, and even our own minds become this deeply woven together, it forces us to ask some pretty profound questions. As all these different worlds of technology keep merging into one seamless experience, what will it truly mean to be human? That's definitely something worth thinking about. Thanks for joining me.